So let's do 3. Y equals, I got sine, then I've got pi x, that whole thing, squared. And then I got another, oh, parentheses there. I got squared there. That should be squared. Is that okay? All right. So then I'm going to take the derivative of the outside, which is going to be cosine pi x squared. Agreed? Times the root of this, which could be either, so who did this problem first time?
Danny did.
Fuller? Just we'll let you do this problem, okay? This Fuller. All right, so now you're going to do the root of this inside. What approach do you want to take? Well, you got two choices. You can either make this very ugly, in which case you can take the root of the outside and ignore the fact the inside is not right, or you can distribute the square first. Okay, so then I'm going to take the derivative in respect to x of pi squared x squared.
I'm confused because I'm pretty sure you helped me with this one.
I might have. I don't think I wrote that as an answer. But let's do it better. Let's do it better. If I did that, it's my fault. Let's fix it. Okay, how do you take the root of that part?
Remember.
Okay, so pi squared is like a number 1 3. Wait a second. Pi is sneaky. It's a number, isn't it? It's not a variable. So don't take the derivative of that. That's just a number sitting there. So it's like 3 squared should be 9. Just like that. Is that okay? So if we treat that as a number, how do I take the derivative of some number times x squared? 2x. Okay, so that's going to be cosine pi x parentheses squared times 2 pi squared x, right? And then I'd probably put that in front.
I thought you're supposed to take out the pi squared. If you put a 3 there, you take the derivative of that, and it would just disappear.
No. It's like 9x squared. You take the derivative of 9x squared.
18x.
It wouldn't be 2x.
Right.
Oh. Yeah.
Makes sense? Because the pi is tricky. And every year that comes up, somebody's like, I don't like that at all.
I just did it.
Right here, right? But then, instead, so I'm going to go ahead and go y prime equals cosine pi x squared times the inside, which is 2 pi x, because I'm making that now blurry, times the root of that, which is just pi.
Yeah.
That makes sense? And then you just clean it up.
So it looks like she cleaned it up and she added the thing in the back.
Yeah. It looks like she fixed this and then put it in two places.
Yeah.
Does that make sense, Lauren? No, yes? You good? All right. All right, 4. 4 anywhere?
Yeah.
Right here. 4. Rise to the back.
I think at the bottom is the final
You can't simplify. There's no obvious step to simplify after that.
Find it and then through the front, so you have to take it away from the back.
Yeah. I mean, I got there before.
I'm okay? 6 okay. So I heard it. I'm doing 6. Doing 6. Let's do 6. Right there. 6. Y equals sine x, not sine x, sorry, that's wrong. Sine of cosine x. Oh, yeah. Didn't know you could do that, did you? Yeah, you can. Okay, so I'm going to make the inside blurry because that's ugly.
Ugly.
Okay? Then I'm going to get y prime equals cosine. And this part stays unchanged, right? Times the derivative of that. What's the derivative of that? What's the derivative of that?
Just precise.
Can we look at the weather?
44 degrees Fahrenheit.
Negative sine x.
It's also 111.
Now, for make it look better, first I move that to the front. That's it. Okay. All right. Okay, hold on a second. I have two people all put together. Try it one time. So I'm going to leave the first one alone. Times the derivative of the second one. Are we in agreement?
Yeah.
What?
Can't use the tan identity.
Tan identity? You could try that. Oh. He didn't want to do that, so we're doing it the hard way. Plus the derivative of tan 2x times cosine x on 2x unchanged. Great?
Yeah.
Okay, now I just get a piece at a time. Tan 2x, nothing to do with it. We're already done with it, right? What's the derivative of cosine 2x?
Negative sine 2x.
Except you have to take out chain, right?
Yeah.
So it would be negative 2. I got to pull the 2 out of there for no good reason. That's not good. So negative sine 2x times the the inside, which is 2, plus derivative of tangent. Once you memorize that, if you haven't memorized it, it's 1 over cosine squared. It'll save you a lot of trouble. Remember that.
Oh,
Mine was just cosine squared.
you read
Times
it like
chain, which is 2, times cosine 2x.
so whatever's inside of tan just goes in the 2 inside of the cosine.
Just like everything else. We're going to get this horrific function by the end of the year where we have this like function up there. And it's going to be the derivative as if that was the normal thing, and then we're going to tack on the derivative of the chain, and it just gets ridiculous.
Don't
Doesn't
erase
matter.
it.
Chain rule works in amazing capacity in all ways. All right.
Don't erase it.
Tempted to find out whether or not whatever cosine that is a quotient rule. Sine, cosine, cosine, sine. I would clean this up. So negative 2 sine 2x tan 2x plus 2 over cosine 2x. Cancel out one of the two cosines. 2x's. And that's probably good enough.
Where'd you get the 2 from?
Oh, the chain rule. When I take the derivative of I take the derivative of cosine 2x.
On the other side.
Same thing. I have the derivative of tan 2x, so 1 over cosine squared 2x
So
times that was not at x, so that's tack on the chain.
So it is 2 over cosine squared. Oh, I was right. And you said I was wrong.
Yeah.
I'm talking about the tangent part.
Can you do?
I do. Did Miss last part of the sentence?
Can you do secant instead of cosine?
Sure. Then you have secant squared times cosine 2x. Oh, I have it. Totally. Although you really should be able to cancel those out. That might cause some confusion. Not much. Y equals sine x. I'm going to rewrite it in the form. This is the form it actually looks like. When you put the little 2 up there, it's actually where it actually goes. So, derivative. Cardio. Can you read it?
Power rule.
Kind of.
Put
Chain
it
rule.
on front.
Make this blurry. That's probably
Okay.
2 sine x.
Cosine.
And derivative sine cosine x. I got to tell you, by the way, this one here on tests is pretty much gold for me if I want to make you guys lose points. I don't know what it is about that problem, but it is brutal for some people.
That's weird.
So,
Yeah, it's like it's just because the 2 looks weird. You just put sine squared x.
that's what it means, right?
Yeah.
And once you get there, it's really easy to do it, Channel. So you see a lot of weird things when you're teaching this, and this is one of the ones where there's like 1 in 3 people. This is a real blind spot. They have real trouble with this problem. Yes.
I thought you would use the product rule. Don't you have these?
Why don't you use product rule?
There's another side to the side.
You can do that.
Okay.
All right, let's do it. Let's do it. I'm a rebel. I'm going to go another way. You can totally do that. Totally, let's do it. Okay, what's the derivative of sine x times sine x? Chain rule. Sorry, product rule. Sine x times cosine x plus cosine x times sine x.
What's that?
Simplify. Totally, do that. Totally. Math still works.
Can you do the project rule number 7?
I did product rule number 7. Oh, that's so the problem when I take the derivative of this is I don't have any derivative of that without a product with a chain rule. So I did set it up as initially as a product rule, and then I tack on the derivative of the chain. Right? Because that I don't have any derivative of. In this case, by breaking it up this way, you do know what the derivative of these two signs are. Right? You know what the derivative of sine x is.